Welcome to a new series of the Algorithms Research Seminar on Instacart. My name is Omar Alonso. I'm a Senior Engineering Manager. And I have the great pleasure to introduce our speaker today, Ricardo Baeza-Yates. Professor Ricardo Baeza-Yates is currently a research professor at the Institute for Experimental Artificial Intelligence at Northeastern University. He was previously a CTO at Intent. Before that, he was a VP at Yahoo Research. He's an ACM fellow, an IEEE fellow. He got his undergrad and master's degree at the University of Chile and his PhD at the University of Waterloo. And he is the co-author of this phenomenal book on information retrieval called Modern Information Retrieval. So if you happen to work on search, you should definitely read that book. And without further ado, great pleasure to have Ricardo here on board. Take it away, please.
Thank you, Omar, for the invitation to give this talk, and I will share my presentation right away because I have a lot of slides. So I hope to cover everything. Sorry. Are you seeing it well now?
Yes.
Okay. So I will basically talk about the bias on search and recommender systems, and some part of this talk is in the paper Bias on the Web that I published in June of 2018 in Communications by ACM. So you can go and read maybe half of this talk there. But also, I gave this talk in ACM Brexis last year in Rio de Janeiro. Well, was supposed to be in Rio de Janeiro, but because of COVID was remote. But it's basically an updated version of that presentation that is also available on YouTube. Well, sometimes in San Francisco, we have sightseeing like in, at least colorful, like in Rio, that you remember this time too, before COVID. And before I start the talk, let me tell you what I'm doing now. I'm half time of my job is in Northeastern University that has many campuses, 2 in the Bay Area. There is a distributed institute called Experiential AI that basically has 2 things that want to focus. One is the human in the loop, although I prefer to talk about the human in control and machines in the loop, but most people already is using this human in the loop thing, that basically we cannot let machines take decisions alone because they make too many mistakes. And you can check my Ethics in AI seminar also that will be available soon in YouTube, and we will give it here in the institute, so you can register that time. But also that we know that there's a strong dependency on big data, and many times we don't have better algorithms, we just have more data, and that's part of the problem. We need to add semantics, we need to add knowledge, common sense on our solutions. And one reason is to get rid of bias, or at least mitigate bias, because sometimes it's very hard to get rid of that. So let's start with a very high-level view. It's my own taxonomy of let's say, web-based systems. So here we have 2 types of data, and structure. We have 3 types of queries: explicit queries, implicit queries, and unknown queries. And this is my own classification. So sadly, because of historical reasons, the structure and structured data divided very early in computer science, and they look like very different fields, but now recently they are becoming more and more closer because all data has, it's basically semi-structure. It's not a pure one single type. Recommender system is when you have an implicit query, mainly it's the context. Sometimes you have a query too, but most of the time the recommendation is on the context of what the user is doing. And finally, in data mining, we find anomalies, we find patterns, and those are the answers for things that we should query, but we don't know the query. So we discover the query using data mining. So just for the young people, I see many young people in this talk. Maybe they don't know much history, because that could be a bit of old history. But what I have here is maybe one of the most important papers on databases. And this was published in 1970. So what is important here is that that was 50 years ago. So 50 years ago, we can say that relational databases started. But maybe you haven't noticed, and it looks like today we have these two different points of view for data, like search engines in the web, or say a relational database system that has been evolving in things that are more unstructured. But I want you to check the label here. This was labeled as an information retrieval paper because information retrieval is much older, it's 70 years old. But sometimes people forget. So databases started as a branch of information retrieval. And of course, data mining is newer. That's about 30 years old. So basically, in 40 years, all these fields develop. Now, before I start, I think we should have the same semantics for bias. This is not something that also has a consensus, so it depends on who you ask. So I will distinguish three types of bias. One will be the statistical one, which is the typical one that you do some measurements and you find that there is an accuracy of the values. Let's say you have a normal distribution and then you have some imprecision, which will be the variance of the distribution. But you have some inaccuracy to a reference value, and this is a systematic inaccuracy. So this is bias. So bias has to be systematic, always in one direction. One problem what we'll see is that sometimes we don't know the reference value. So for example, we don't know what should be the right percentage of, say, a given gender in this talk. We may say it should be a given percentage, but maybe some people will disagree. The second bias is the one that comes from your culture, and that's encoded in your language. It's encoded in your education. It's encoded in what you do and so on. And then we have cognitive biases. These are the most dangerous ones. Here is one of the typical things that you find on the internet. These are the 20 cognitive biases that screw up your decisions. And here is one of the most important one, number 7, confirmation bias. You see something that is aligned with your beliefs and then you believe it. So this is what the fake news use. Basically manipulating, nudging, what is called nudging your confirmation bias. So there are many more. There are more than 100 cognitive biases. You can find this codex in the web that with certain taxonomy of them. And this depends on every person. So there are a lot of things that are here, personality issues that can affect the person. So the motivation today is that most web systems are optimized by using implicit user feedback, and most of the time this implicit user feedback has a label that is positive. For example, a click will be a positive feedback. Or let's say no clicks, most of the time will be not a positive feedback, but in search, sometimes that's not true because the snippet may give you the answer. So at Yahoo Labs, we wrote a paper that was entitled when no clicks are good news, to see how that can be also analyzed. But one problem with click is that clicks can only be done on things that are shown to us. And I will get back to this. So basically the system is partly writing the future because the system is choosing what you can click or not. And then you have, in some sense, self-fulfilled prophecies, and of course, suboptimal solutions. And I will show you that not only we have filter bubbles for users, but also we have kind of echo chambers for recommender systems. And I will get back to that at the end. Sometimes also these systems are competing with themselves. So you can think that if you have many different ML-based models, maybe they are fighting. For example, the typical example is the people that work in user experience versus the people that work on monetization. Maybe when one team is improving, the other is being degraded, and so on. So it's not easy to have a single optimization function for all your system and balance, for example, user experience and monetization. And I will get back to monetization at the end. So the premise today is that any human data has bias, and it's natural. So it's normal. You need to have some kind of systematic deviation to have information in data. But we're talking about observational human data, of course, because if you do an experiment with humans, maybe you can control part of the bias, but of course, it will not be ethical to do experiment with humans, and some social networks did that in the past and got a big slashback from media. So there are many cultural biases. I will not read this list. It's my own list, and you can add yours. Of course, there are statistical biases. I will talk in the way, for example, sampling, validity of the data, completeness, and of course, spam and noise. And of course, we already said there are many cognitive biases, and here I will encode also the whole user. So I will call it self-selection. So every user has some self-selection bias in her or his choices. Now, if you take the past years, a lot of people have focused on very important biases we have still, like gender, race. Remember, race is a social construct. DNA tells us that doesn't exist. Age, religion, and so on. However, if you take, say, Twitter data, which is the most public data today to do, like, say, social analysis, well, you can at least find these 6 types of biases in the data. There are more men, there are more young people, it's in dense places of population, it's more educated, usually have more money, and of course, they lack technology. So in many cases, using this data will not be representative, and I have been working on how to make Twitter data representative. And if someone is interested, I can send you some papers if you write to me. But what I'm trying to do here is to basically tell all the people all these other biases that affect all of us, that are as important as other biases, because they affect to all of us, not only to, say, a minority or a given category, even if the category is nonsense, but some societies use it. Of course, this is an attempt to do an unbiased view, but of course it's personal, so surely it's bias, and one main problem with bias is that you don't notice your own biases. So the first problem with bias is awareness, and this is one of the main purposes of this talk. So you are aware of all the issues. So the question is non-technical. This is a question of society, and every day it gets more important when you see the mistakes that AI-based systems do when they take automated decisions. So you have biased data. Always you will have biased data, and an algorithm. And here I disagree with the people that say that a model is not an algorithm. Yes, the model by itself is not an algorithm, but you need an algorithm to run the model. So at the end, the model is embedded in an algorithm, and together is an algorithm. And of course, the model is the data of the algorithm, in addition to the data that is receiving, say, online. So the question is, should be neutral, should be fair. Most of the time, people don't even ask this question, and then you get the same bias. But even worse, we have examples where the bias is amplified by the algorithm, by the optimization function that you're using, or other possibilities that I will mention a few in this talk. So it's very hard to answer what is fair. We, as different societies, we really struggle about fairness, and the last 50 years, 100 years, a lot of things have been improved for women, for minorities, and so on. But still we are on doing basically equity, affirmative actions, like say gender parity, or trying to have more minority involved in the decisions. But the real thing that we want is justice. But justice takes a long time, because that means we need to basically remove the problem that created the injustice, and you know that will take time. So The answer is not always we need to worry about that. If we need to worry about this all the time, will be too much. But of course, we need to worry about this if you harm people. And in recommender system, most of the time you harm people in one way or the other, and we'll talk about that later. So it's not only that you are harming a user, but also you can harm an actor of the system. If you are, say, a digital market and you are an e-commerce platform that you are selling products of other parties. So solutions for this problem, this is not the main part of the talk, but I think it's important that you know the three approaches. Of course, you can debias the input. This will be the most effective one. But for that, you need to know what is the bias. And sometimes the bias is much more subtle than, say, a gender bias. The second one is to tune the algorithm, and this has been used a lot on search. For example, learning to rank that is able to deal with some biases like ranking bias. We will talk about that later. And the last one is to debias the output, but then it may be the simplest way to do it, but then you lost already too much information. So let's say you do a search on LinkedIn, you get 20% women, you cannot have gender parity. The only thing you can do is to re-rank to have more women on the top, but it's not completely fair if you want to have a 50-50 distribution. So, as I said, the main goal of this presentation is bias awareness. So in 2017, the ACM US Technology Policy Committee did a statement on algorithm transparency and accountability. I'm part of this committee on AI and algorithms today, but I was not at that time. And these are the 7 properties, I will not read them, that algorithms should have. But the truth is that most systems don't have any one of these properties. Of course, today we're talking about awareness. So that means that the system should be aware, for example, of all the biases that it's handled. But most of the time, the system doesn't know, maybe knows 1 or 2 biases, but not all of them. Here it's important to remember that systems do not need to be perfect. They just need to be better than us. And there is the possibility that machine learning systems, even that they are biased, they are more fair. In what sense? For the same input, they always take the same answer. So basically, unless you have a pseudo-probabilistic system, these systems are deterministic. And this is important because humans are not deterministic in the sense that upon the same input data, sometimes they take different decisions, especially in justice. And you know that also happens in the stock market and so on. People many times are irrational, not rational. Okay, so bias in computing systems started more than 20 years ago. There were a few papers. I think there are 3 landmark papers here related to machine learning and related to computing systems in general. And it's very interesting that this Friedman and Nissenbaum paper is still valid today. And it's a pity that people didn't read it earlier and didn't start working on these topics before. So I started to be interested in bias in 2007, I think, was the first time I started working on a problem that was about bias. But really, it took some years to realize that many papers I have been working on were about bias. So basically, to be aware that really what I was trying to address was bias in these systems. But it took some time, and that basically 10 years later, I wrote the paper of bias on the web. So there are some key issues for machine learning that we need to remember. So in the web, distributions resemble a power law. Those are very skewed distribution, and those are prone to generate bias. Also, we have in our mind kind of a uniform distribution for errors. And remember, all statistic books are biased because the uniform distribution doesn't exist in practice. It's not real. You will never find white noise in any problem. It's just there to learn the concepts. But when someone said that the probabilities 1/2 to make an exam more difficult, well, it's not thinking in real life. Typically in the web, the probabilities are close to 0, right? The probability of a click. And then you have issues with sampling. So do you have the right number of samples? And if you have a very skewed distribution, you have to be very careful about this. And then when you do the sample, do you have the same distribution? And I will get back to that during my talk. So one possibility to think about prediction error is this graph. I think no one has done this study. This will be an interesting research paper if someone wants to do it with me. What is the prediction error depending on the complexity of the problem and the data size that you are using? And here I said, okay, let's say prediction error grows linearly depending on the complexity of the problem divided by the amount of data. And of course, this could be not true because depending on the complexity, things can go wrong. So let's start with all the biases that we can have. So let's start with the data in the web. So this is data bias. Data bias is the main culprit for bias as a source, but it's not the only one. So when even you have Turing awards that say that all bias comes from data, I think you need to think twice about that statement after you see my talk. Of course, the main bias in the web is web spam. We will talk about that. There are a lot of research on that, but of course you need to be aware of that, and most people that deals with search is very aware of that because it's a constant fight for them. But let me give you more subtle biases on the web. This is work I did with Carlos Castillo and Vicente Lopez a while ago, but this is about links in the web. This is the Spanish web. And here you see that there's a correlation, clear correlation between exports of the country and linked domains. Now, if you take all the outliers, you will realize that these countries really are not countries in the web. And you can check which country or which possession is FM. But of course, we use it today for radios, but it's a region of the world that had their own code. So you can do this for more countries, and you will see that more developed the country, higher the correlation. So it's not a proof of causality, but it's a strong signal that this is more than correlation. Cultural bias in content. So this is a paper also with Carlos and FT that sadly is not with us any longer. Here you see the size of web pages, and you can see that there's a big power law to the right, but also there is another law at the beginning of the distribution that opposes this power law, which comes from the minimal effort, this SIP law. And I call this the shame law. So basically, people will do something meaningful until they think that they have done something long enough, which is about where is the average, so 20 kilobytes, including the HTML code. And the same happens with other things. For example, here we have images. And this explains why, if you notice, in South Korea, they have less text. Well, they have many more images. They like visual things. That's a cultural difference. So you see some cultural bias on the works, on for example, in the user experience. And here also you see that in Spain, I don't know why, they don't like images, just text. Maybe that's why I like text retrieval. So linguistic bias. So here, there's a study from this company, Language Connect. It's not a new study, but it's a good example for linguistic bias. They say if you take the top 1 million websites, more than half of them are in English. I cannot audit the top 1 million websites, it's not available, but I think it's more or less true. If you take the top 1 million websites, you will get something like 50%. So the question is, what's the right reference value? And that's why I like this example. What is the reference value to compare? One person may say, okay, let's take what people speak. And their English as a native language is number 3, and it's less than 10%, so the bias will be at least 5 times. But someone might say, no, what is important is the language that people in the internet speaks, not all the world. And there you get, if you include also second languages, that English is about 25%. So the bias is not so bad, but still 2 to 1. But someone may say, well, but that's not important what the people can read. What is important is what is in the web. And according to this other study, the content in English is like 27%. And still you have a 2-to-1 bias. So we have a problem of quality bias in content regarding some languages. In my bias on the web talk, for example, I mentioned that only 5% of the languages that are alive today have a Wikipedia. So we are basically discriminating the other 95% that maybe not too many people speak, but it's a lot of knowledge that we will lose if we lose those languages. You can also have geographical bias in content. So this is an example of news recommendation, and this is Chile. And you can see that the regions of Chile on where a tweet is generated and where a tweet is consumed. And you can guess that the top region is the capital, is the metropolitan region of Chile that has about 40% of the population of the country. So if you do the typical news recommendation system, you will get that most news are from the capital, and then you will read only news from the capital. That's true in most countries. But with one of my PhD students, we address many problems of bias, and one of them is here. And he found that if doing experiments in the wild, people prefer systems that basically give more weight to local news. And this is a system that basically has a geographic mitigation for geographic bias. I'm sure many people have seen this paper that was published when NeurIPS had the old name. Not sure if I have to change it or not. That's a good question about bias. We keep the name of that time, or we update it. And here in these key analogies, you see that most of them had a stereotype. So for example, if she's a nurse, he's a surgeon, or if she's a diva, and we know that there's a negative connotations there, he's a superstar. So I did some research to see if most journalists in the US are men, because these are US news. And I found that yes, the answer is yes. Like 70 to 70% of main journalists are men at work. But I found at the same time that at college is the inverse. So there is another bias here to get a job if you're a journalist. And finally, to finish with the data bias, this is another example of Eduardo's thesis. These are biographies of women in Wikipedia, and you see that something changed on the French Revolution, yes, égalité, and then the number of, let's say, famous women has been increasing on time, and now we are close to 25%. It's still far from 50%. So you can say there's nothing new here. This is systemic bias. However, there is a much bigger bias here, and this is the problem with bias. Sometimes the bias is hidden, like in a recent result in a court in Italy, where they showed that a company that does food delivery was biasing people that couldn't deliver food at dinner time. So you see, that's not a trivial bias. So you need to analyze the algorithm of what it's doing to find it. So what is the bias here? And this will be obvious after I show it. Like anything that is obvious, only it's obvious after you know it, and there's a book about that, is that most editors in Wikipedia are men. So for example, the women that disclose their gender in Wikipedia, this is partial information because it's not compulsory, is about 11% for biographies. Maybe the real number is 15%, but you see 50% is worse than 25%. So this bias is much more important. And please, for the women here in my talk, write more in Wikipedia about your role models. The next bias is the bias of all of us interacting with the web. I call this the activity bias. Some people also call it the engagement bias. And it has to do with, again, the Zipf law. So basically, many people do little, and few people do a lot. These are the influencers. But it's not because there are two types of people, it's because we have two types of modes. So most of the time we are working in our own long tail, while the rest of the time we're doing the same as all the other people do. We are not that unique. There are many things that we all do all the time. And this is a great paper that was also a product of Yahoo Labs that basically is called, I don't remember exactly now the title, but has an interesting title because it says extraordinary people in the title. And this is the reason that we have popularity bias in recommender systems, because it's not like we have information at random. It's more like we have information about popular items, and the rest of the items we have less information, and we'll get back to this. And this slide is courtesy of Pablo Castells, one of my favorite recommender systems researchers. And basically, we can think on ways to improve this, like using novelty, but this really doesn't solve the problem because of this property that the ratings are not missing, not at random. So basically, we have a bias in what we observe, typically similar to police bias on criminality. And when you look at the test data and the training data, you will see that clearly you will favor popular items. And there are a lot of papers that addressed this 10 years ago and keep being improved. So we can keep trying to mitigate this kind of data, but you have a reinforcement loop coming from the interaction of the user of the system. I will get back to that. And this is the problem. It's not something you can fix with a fixed model. This is something that you need to fix dynamically. So this is a problem for IR evaluation methodology. Here, there's one example of bias in one of Pablo's paper with his PhD students. And here I also mentioned a paper I wrote with Paolo Boldi and Flavio Chirichetti that shows that 25% of the queries, for example, can be answered with less than 1% of the URLs. So these skew distributions are always present in everything. So this is the problem. So we don't have a world where things are randomly distributed, or basically where people are identical to each other, because that's not reality. It's in the right. We have exactly the worst case where we have a mixture of both things, and we need to deal with that. So there are many papers in the last years to get rid of popularity bias. Here's only some. One was the Best Paper Award in SIG-IR 2018. But basically, this is a very important problem you need to solve in your recommender system if you want to be fair with all the people involved, not only users, but also the actors of the platform. And this has to do with how you recommend in the long tail. So typically, we try to do personalization. But the problem with personalization is that for most people, we don't have enough data. And also, there are privacy issues. So the answer is to do personalization, but of the context. And then, although this is also some kind of personalization, I prefer to call it contextualization because I don't need any information from the person. I don't want to know the person. Maybe I want to know a persona. And this is similar to what is doing now Google. If you saw the recent news about flocks, that basically is some kind of k-anonymity on people. And with this, you can do much better because you will have more data because you are focusing on the task. And of course, quality filtering is one of the ways to do this, but you need to extend it to any other technique. And here is an example of that. So this was another paper that was published by Yahoo Labs. So let's say we take photos with Flickr that were taken by a camera with GPS. So we have the places and the time those pictures were taken. And so we get this time path of people, tourists in a city. So if someone goes to Barcelona and tells me that they have, let's say, 2 hours before taking the plane after arriving in a cruise, well, I can tell them they have to start from the main square, go to the cathedral, then to the main market in Las Ramblas, and then go to enjoy the the Spanish Square, and then you're closer to the airport. And I can tell you exactly how much time you will take, how much time you will be there, and even how many pictures you can take, but you should leave some degree of freedom to people and not over-personalize. But activity bias also affects content. So in how we contribute to the system, and here there are 4 examples from different data sets, and this was with another of my PhD student, Diego, that now works at the Wikimedia Foundation. So looking at the percentage of people that produce half of the content. So in Facebook, we found that 7% of the people produce half of the content. Of course, the other half was 93%. So you can read now these circles. In Amazon reviews, 4% of the people wrote half of the reviews. When I said this when I saw this, I said, Diego, cannot be true. I mean, these people who doesn't have so much free time, are them being paid? Well, we didn't know. But 1 month after we published this paper, and I don't know if there is any causality, someone in Amazon will tell me in the future, Amazon started to sue fake reviewers. This happened in October 2015, and this continued in 2020 and until today. At that paper, also we look if the quality was correlated with the production. And using this text entropy measure, we found that was a good correlation with the number of stars, helpfulness of the reviews. And if you take that in account, then the 4% went down to 2.5%. So basically 2.5% of the people wrote 50% of the best reviews, so which is another indication that they're being paid because they have better quality. Also, we look at Twitter, and this is related to Nielsen's rules of internet participation that said that 90% of the people are lurkers, 9% of the people just answer to the 1% that are basically generating content. So in Twitter, 2% of the people generates half of the tweets. Of course, they're not being paid, but I guess this is a indication of how ego works in the internet. And finally, maybe you don't know, 2,000 people wrote the first half of the English Wikipedia, and of course they were paid, and maybe they did a fundamental difference in what we have today, because for most people, they have the cognitive bias of not, basically not contributing with something that is empty. Imagine that someone tells you there's a new project, Wikipedia, and it's empty. Please contribute. It will be very hard. You need to see at least the glass half full to contribute to something. With Diego also, we look at the problem I was interested in. So basically, it's related to attention bias, which is another part of our data economy. So attention is scarce. Do you know how many websites there are? How many gets more than, say, 1,000 visits per day? And here we found that if you take all the changes in 1 month on Wikipedia, then only 31%, sorry, only 69% of them are visited the next month. Of course, this is a temporal measure, depends on the time segment that we choose, but this is like an upper bound. But also we checked this Twitter collection we had access, was a large Twitter collection, almost all Twitter at that time, about 10 years ago. And we found that 1.1% of the tweets are done by people that don't have any followers. So no one will see that tweet, because even maybe you can see it by searching it, but of course you need to what to search, because the ranking for them will be on the bottom of the ranking, and we know that people don't look more than 20 results, and I will talk about that in a while. So the next bias that we find now is when we have this search or recommender system and we need to sample data. So we need to worry about distribution, but also need to worry about the sample size. And this is maybe the main bias today, more than distribution, is how much data we consider. And of course, we have algorithmic bias. And for me, algorithmic bias is bias that comes from the algorithm, not from the data. So it's additional to the data. People really put all this together when they say algorithmic bias. They're talking about data bias, but I think that's a bias. That's a language problem, and we need to distinguish the source of the bias. Here is a paper that I published in CIR 2015 in the industry track, basically showing that many people don't know that the typical error formula diverges in near p equals 0. So basically, very low probabilities, like probability of a click. So here I have an example. If you take only 80% confidence interval and something that happens 10% of the time, which is a large probability in the web, basically you get a huge error because instead of taking 2,300 samples, you will take just 900 samples. So please take this in account when you want to sample something to measure if a click is happening, because if you have a click of 1 on 10,000, this number grows exponentially. So you will need to have a very large sample. And for the same reason, when we start sampling with the right sampling algorithm, so basically reversing the distribution, you will see what happened here. Here is a collection of 50 million queries that are have a power law distribution. But when we get to a sample of 1,000 queries, we get a very different distribution, which is not what we want. Even for the 100,000, we already had an issue in the tail. So for this, you need to use a special stratified sampling that I have in the same paper that basically switches the sampling approach in the tail. The tail is not really a real long tail because it's basically just unique items that cover a very huge part of distribution. In search, 30% of the queries are unique for mobile, and up to 50% of the queries are unique for desktop. And let's go to extreme example of algorithmic bias so you understand the idea. So let's say you have a system like Flickr where you can upload the picture and then add tags. So the user writes London Eye and Thames, and you say, you are a bright engineer, you say, oh, let's help people, let's do a correlative filtering approach with tag co-occurrence and even deep learning to suggest tags. So what is the problem with this? The problem with this is that people will use it. And if people will use it and it works, next time you will write just one tag. People is lazy. But even some people say, well, but they're using deep learning. Let them generate all the tags that will click them and the good ones. So what is the problem? You will not get any new tags because new tags only can come from people. So basically what the system is doing is killing the taxonomy and cannot improve, will basically stall in the set of possible tags. Big mistake, especially for any new picture that has something that no one has tagged. So please don't do this. If you have a taxonomy, don't help people. Let people be lazy. But you can use this system to do query expansion. So you can use it for search. Now, interaction bias. Your system has a very nice interface for the users. The users, remember, have self-selection bias. And here comes maybe the main problem with bias today, especially in your systems. And to understand this, I will let you watch a few slides. So just watch. Not sure how many people was able to read the bottom comment. I will put it again. But I can manipulate how you read. And that happens all the time. So for example, if you have a system like here, this obviously very well-known e-commerce platform, and it's a biased example because I search information retrieval or something that my name, so my book came first. Here we have exposure representation bias. This is the worst bias today in recommendation system. What it means, that basically is like the iceberg problem. We are only looking at the top of the iceberg, but much worse than the iceberg because maybe there are thousands of books below, and in some cases millions. So we are looking at the ice cube on the top of the iceberg. The rest is hidden. This is exposure bias. Then we have position bias. So you look first to the left top corner. If you read normally that way, in China or Israel, they will do it differently. And of course, we have ranking bias because people believe ranking works and they click more on the first position because it's in the first position, not because it's the best. We have social bias. Some people choose depending on the number of stars. So other people is changing our judgment. And of course, we have many other interaction biases, like what happens if the person doesn't scroll? How many people scroll? And so on. And the problem that these are dependent biases, and there's no research yet on this field that I know, in spite that I published this figure more than 2 years ago. And one problem is that the ones on the left come from the system, but the ones on the right come from the user. So how we detach or compose the analysis of this to understand what is really happening, and this is very important if you are really working on a nice balance between user experience and monetization. This is the example from Mediative that shows that basically people do look at some places in the screen using eye tracking, and you see how it changes the position bias from 2005 to 2014, when other kinds of answers were included in the search page, in the answer page. And here is a real distribution of clicks. And one problem with the number one is navigational queries in search. So people, because they are lazy and they don't want to type the URL, they search. But they're not looking for information, they're looking for a website. So if you take this out, it's about 15%, you still have a ranking bias, you see. And here you have an example of interaction bias. So some not very smart engineer in the first search engine, homework, what is the first search engine, decided that we need to search the results 10 by 10 and not depending on the size of the screen. Interesting, right? Some mathematical bias there, also related maybe to the number of fingers. So how we debias that? Well, if we put the same graph in a log graph, you will see something like this because of this interaction bias. And because of the position bias, we want to find the real distribution. That will be something like this, the red line. So the only 3 published papers about this, all from Yahoo Labs. It's not known exactly how other search engines do. The last one got the best paper award in Wisdom. But this will be ways to handle the problem, debiasing the input. Then the other people that have been working on, for example, learning to rank with bias, here I have one of the first paper by Thorsten Jochims that was also a best paper award in Wisdom. And there are people like one of my granddaughters, academic granddaughters, that look at fair rankings. And this will be debiasing the output. So these are the 3 types of techniques that I mentioned at the beginning. Now, I will skip what is a fair ranking. I think don't have time for that, but you can look at their work. So what is next? Well, the last one. This will be second order bias. So this is basically the user doing something with the output of the system and put it back in the web. So let me show you the first paper I did on bias that was about this problem. So let's say you're writing your next blog. So here's your new page for the blog. And then you search something. Of course, this will have the ranking bias. So we will look only on the top results. And I copy this here. Of course, I'm not doing plagiarism, so I will put a link back to the source. I will put this in quotes, and I will mention the author. These 3 things are the difference between plagiarism and research, by the way. But here I feel some shame, so the shame law, because there's nothing from me, so I put part of the context. So not much, but this will be a typical mashup, your opinion together with other opinions. And of course, the ego comes in and you put your name and you publish this back to the web. So in a paper by Fortunato et al., they claim that this bias on the positions was not really important in the ranking. But in this paper that we published later in the web conference with another of my PhD students, Alvaro, and a colleague, Nivio, we showed that the semantic redundancy grows by 35%. So basically, we found the ancestors of every page. So this paper is called the genealogy trees of the web. And we showed that this is a problem. So basically, by doing this, you are reinforcing the belief of the ranking function of the search engine that those things are good. So basically, you are reinforcing the ranking function, not the ranking position. And this is even worse because that means that the rich get richer, the Matthew effect, and the poor get poorer in the ranking sense. And the last part of the feedback loop bias is personalization. So basically, your interaction goes back to the system. And this is the most dangerous part. The feedback loop bias, and this has to do with personalization. And basically, I may know Omar from a long time, but still I cannot recommend something new to him because it's not in his data, because it's new. And if he knew it, he would like it, especially if it's meat. So here you have things that we have been doing to improve this: diversity, novelty, serendipity. I also would like to have my dark side, so to see the extreme case different from me, because I want to know the size of the universe. And this is important because today we don't know that in the recommendation sense. And then we have these echo chambers in feedback loops. Maybe you read the book of Eli Pariser, but there was an interesting paper in IEEE 2019 about feedback loops in the exploration systems. And the truth is that then you have a disparate impact in the system, complete system. So basically, you have an echo chamber of the recommender system that will be, you can think, the union of all the filter bubbles of its users. Can we do better? Yes, if we are using reinforcement learning, let's say reinforcement learning with deep learning behind, although many recommender systems today are using static models, which I don't think are the best when you have a lot of change in the world, you need to have enough new traffic to basically approximate well the changes in your world. That means new items, new users, changes of taste of users, and so on. New problems on items, and so on. Otherwise, we will always live in a suboptimal solution. And I have some results on new research that I'm working there. Also, we have all the problems of fairness and ethics in e-commerce systems. And a few years ago was about Amazon. Today it's about Facebook and Google. And for example, should marketplaces sell in their own marketplace? There's a very interesting paper last year from Singapore. So I think this is something that will be interesting for Instacart people. And you need to regulate this data symmetry that you have if you are basically generating a digital market for other people. And very important, I believe that fair markets will be better revenue-wise in the long term, because you will know better your actors, both users and providers of either content, products, or whatever. And there are some interesting trade-offs there. So the last point, professional biases. We have many biases. One, we forget that most companies, most institutions will never have big data. They're too small. And we have a small data a negative bias. So I have an opinion paper in KD Nuggets if you want to read it about 2 years ago. What about the design implementation? I point to this on my 2018 paper using this nice example in 2015 about data analytics. So in data analytics, they show that what you know changes your analysis. And very nice, very recent, last December, a paper appeared in Archive that basically shows that the bias of coders, especially in the user interface, changed the system. So something I assumed that was true, now at least it has some indication that is true. And in the evaluation, maybe there are many, many problems, like you have to choose the right experiment, you have to choose the right test data, you have to choose the right metrics, you have to choose the right baselines. And here I pointed to a nice talk in ESCIR of Julio Gonzalo that is available on the web. Now, what we can do? Well, we can do many things, like analyze for bias first in data. Interaction, try to make the user aware of all the biases all the time. Help the user, give more control to the user. The user is not stupid. The user knows more than you think. Design implementation, have people contest you all the time. Top users, top ethics people, and so on. From the design to the implementation. And finally, evaluation. Do not fool yourself, especially if you want to publish a paper, but also if you are working in a company. You need to compare with the state of the art or with the best you have. So the final take-home messages. So remember, systems are a mirror of us. So the good, the bad, and the ugly. So the web amplifies everything, but the good thing leaves traces. And we have to stop this vicious bias cycle that we are creating ourselves. We are the designers of the system. We can control these things. And remember, we should be fair. This should be obvious, but sometimes people prefer to monetize more than being fair. So I think that if you lose 10% of your revenue, in most cases, nothing will happen, but the system in the long term will improve. So I can take questions now. Remember, there are 2 conferences that are important in this area, and sadly, one of them is happening right now, and so I will go back to the conference after this talk. It's FACT. Today is the last day of FACT, and there are many interesting papers that you can look there.
Thank you so much, Ricardo, for a wonderful talk.
I will share the slides for you in PDF so you can send it to the people.
Thank you.
We do have a
couple of questions in the chat. So if you had a few minutes, if you want to address them.
Sure, yes.
I'm going to read them to you. The first one is from Cheng Liu, and he's saying, does the bias depend on devices customer use? For example, iPhone, iPad, and the Mac have different screens geometry, which results in different positions of each choices.
Yeah, yes, I believe the answer is yes. I haven't seen any research on that, but I believe your interaction and I can reflect on mine is completely different, let's say, in a mobile phone and in a desktop. For example, there are some results from search that corroborate that. For example, maybe counterintuitive, but people use longer queries in mobile. Why? Because when the internet is not so good, you don't want to do the query again. So you want to minimize the number of queries. So strangely enough, even though that is harder to type in a mobile phone, people prefer to type longer. So they only do one query. So I think the answer is yes.
Cool. Supark is asking if there's any research been done on the degree of bias across different browsers.
Not that I know of. And here I think the answer is that it's less bias here because browsers are not that different. But maybe there is issues that are important is basically the amount of privacy. Let's say DuckDuckGo provides different things than the other search engines or most search engines. So the question is, do people do other things that they don't do when they are more public? I guess the answer is yes there.
Simi is asking if you can talk about any industrial/company work that has been done in Rex's space using reinforcement learning.
Yeah, that's a very good question because I have the question myself. When I was at Yahoo, we used for some kind of system, we use reinforcement learning, but I think today not too many people is using them. So my question is, how do you manage for bias if you cannot be learning all the time? Are you training your deep learning system every day or every week? What happens in the meantime? So this is a good question. If someone has a nice example that they can mention in the chat of a system that uses reinforcement learning, I want to know, because I think one of the pros is that you can do more exploration. You can try to learn your world more and be more fair. So currently, if you don't have exploration, you cannot really learn the world continuously. And who knows if the function that you're optimizing is learning the right things when you are doing just deep learning.
Ricardo, we have like 4 more questions.
I can do it, no problem. So
okay, sure. So
Goldshan, we have 100 people in the talk here, so.
So Goldshan is asking, do you think we should encourage positive bias to cancel out the existing bias?
Of course, I mean, one possibility is that. For example, for example, if you have a people search system, we should encourage better gender bias. The same with minorities or geographical provenance and so on. So yes, I think we need to have affirmative action, but they should be very clearly stated. So they should be transparent. So anything that you do to mitigate bias should be advertised in the sense that saying we are doing this to basically fight this kind of bias. So it shouldn't be hidden, because then this could be a flashback if people find out that they are being discriminated by a positive discrimination. So remember, fairness is something very hard, in the sense that it's very hard to do fairness all the time. So for example, typically you try to do group fairness, but of course you will not do individual fairness to everybody, especially if you're doing gender bias mitigation.
Silvana is saying, we'd love to see more research on how web accessibility affect bias. For example, screen readers versus eye tracking. How do you see this affecting the concepts you talked about?
So a very good question, Silvina. And what I can recommend, because I'm not an accessibility expert, but I did a version of this talk tailored to accessibility experts on Web for All last year. So if you can go to Web for All, this part of the web conference last year, I did an invited keynote on bias on the web, but focus on accessibility. And I put there some ideas on, for example, people that have a color impairment, or people that is blind, and so on. There are many issues that really affect these things, and they should be studied.
Thanks.
I did this talk also in the Algorithmic Fairness Center in Cyprus. So maybe you can find it there in the web, in YouTube. I did it in, I think, early February.
Wow, plenty of answers for that question. Avi is asking you if you're looking at bias in the auto-suggest, in the autocomplete.
Oh, I have some papers on auto-suggest with some people at Yahoo Labs, and of course, there are many biases. Remember, there was also auto-suggest bombing. Yes, this is a problem that you need to be very careful, because many completions today are learned from trolls that basically are doing these ugly queries just to modify auto-suggest. So yes, auto-suggest is a problem that we need to look to mitigate bias. Otherwise, you get basically unethical completions, where some people will be affected even psychologically. So if you see a minority being mistreated in auto-completion, that person will basically go in the wrong direction.
Thanks. Hernan is saying that quality research considers subjects, participants, which are also potentially a source of bias. And what about mixed qualitative plus quantitative evaluation and information retrieval?
Okay, so I think I don't believe much on a small studies, because typically there is a sample bias, and also there is a selection bias on the people doing this. I prefer to only use data that comes from large experiments. So I would say I would prefer to do more A/B testing with many different type of control, to make sure that I'm covering all the possible biases, and not only one. So one problem today is that our control set may have many biases, and we're not controlling for that.
And the last question from Jaya, any guidance on how to trade off user experience and monetization?
Tough question. I would say that one is that don't try to put a budget limit to exploration. Don't say, let's decrease revenue today in 5% to explore. Try to find what is the right number depending on your traffic, because at the end, your traffic will improve if you're improving the user experience and you are basically not trying to put a bound that is basically arbitrary bound on that. And the second is that you have to use a single optimization function. So basically, both teams should use the same optimization function, and this will be very good because they will have to be together in a room. I will suggest what was done on this data analytics experiment. You put like 2 people from each group in a room together. So you have many teams of 4 people. They come up with some answers. They can present their answers. All of them will be different. And then you ask them to again have consensus. And then you have to pray that that's the best you can do. But at least you will have a collective intelligence at work to find what is the best optimization function.
Thank you so much, Ricardo. We really appreciate the time and the effort to answer all the questions from the Instacart team. Fantastic talk. And I believe we'll be publishing, uploading the video to the YouTube channel. So for folks who want to kind of replay the video. Thank you again, Ricardo. Really, really great seeing you.
Thank you, Mar, and thank you for the, I saw like 170 people at some point watching the talk. So thank you for coming.
Fantastic number of folks join us today. So see you later. Bye-bye.
Bye-bye.